I have another one of these fill-in-the-blank triangle proof exercises, but this time instead of doing it on my own little digital notebook, I'm going to do it right on the exercise because there actually are tools so that you can mark up the diagrams. So first they tell us that segment BC is parallel to DF. So BC is parallel to DF. Figure not drawn to scale. Fair enough. And we're going to prove, and it's always important if we're going to do a proof to know what we're going to prove. We're going to prove the triangle EBD. So that's this triangle down here is congruent to triangle EBC. So this one right over here, that this triangle is congruent to that triangle. That's what we're going to try to prove. So let's see what givens they gave us. They say that, and you see when you scroll over it, they show you which two angles they're talking about, that angle EBD or BDE is congruent to angle ACB. So let me mark those. So I just click once to show that those two are congruent. Then they say that these two segments, DE and AC, are congruent. So let me mark those. You just click on them. Click on them once, it does one slash mark. If you click on it more than once, it'll do more than one slash mark. Then we also know that these two are congruent, BED and BAC. So let me put two arcs here to show that they are not necessarily congruent to these other two. So I did those. Now we have this one, BED, which we've already marked. That's BED right over there. Is congruent to CEF. So that's just telling us that CEF, this angle, is the same as this one. So I can put the double hash marks there. And then they tell us that BE is congruent to EF. So BE is congruent to EF. And then finally, they tell us that angle DBE is congruent to CFE. So DBE, I'll put 3, DBE is congruent to CCFE. So now let's try to do our proof. And they've already kind of done a scaffold of our proof, and we need to essentially fill in the blanks. So this first thing, they're comparing two triangles, and they say those two triangles are congruent because of angle side angle. So where can we even make that statement? Well, we have this triangle right over here. We can say it's congruent to this triangle up here by angle side angle, angle side angle, or we could say that this triangle is congruent to this triangle because you have this angle side angle, this angle side angle. So it's not clear based on just this blank which one they want us to describe. But let's go further down in the proof and maybe it'll become more obvious. Well, then they have this blank right over here. Blank equals blank because corresponding parts of congruent triangles are congruent. Once again, it's probably based on which two triangles we picked to be congruent. This is going to be one of them, but we don't know whether it's going to be that one or that one, depending on how this proof is going down. Then they say that triangle ABC is congruent to EBD. So then they say that this triangle is congruent to this triangle right over here. Well, if down here they're making that statement, then up here they must want us to say that this triangle is congruent to this triangle right over here. So we can say that EBD, or maybe I'll say I'll do EBD. EBD is congruent to, so it's EBD, the double arc, double side, triple side, is going to be congruent to double arc, double slashes, triple side. So EFC because of ASA. EFC. There you go. And it filled it in, which is a good indication that we did it right. All right. And then let's see what else can we say. So now, remember, we're trying to prove that this triangle right over here is congruent to this triangle. So based on this, we just said that this triangle on the left is congruent to this triangle on the right. Given that they're congruent, what is useful information so that we can get information about this middle triangle? Well, this middle triangle shares side EC with this triangle over here. So we should say that side EC is congruent to something over here, which will help us set up that this middle triangle is congruent. So based on the fact that EBD and EFC are congruent, EC's corresponding side would be what? Well, it's the side that's opposite the triple angle. So it's going to correspond to side DE. So we could say that DE is congruent to EC. DE is congruent to EC because they're corresponding sides. They're both the sides opposite this triple angle. DE segment DE is congruent to segment EC. There you go, and that worked out. All right. And then they say triangle ABC and EBD, so that's this one and this one, are congruent because And we already went over this. There's multiple ways that you can say they're well, actually no, there's only one. They have this angle, side, angle. Angle, side, angle. That's why they are congruent. So we have angle, side, angle congruence. And then we can say that BC is congruent to BD. Well, those are corresponding sides of congruent triangles. Those are both the sides opposite the double arc. Opposite the double arc, and then up here, opposite the double arc. So that's because they are corresponding parts of congruent triangles. And then finally, so let me mark those off. So that is congruent to that, corresponding parts of congruent triangles. And then finally, we can prove the statement. And actually, you could have probably guessed what this last one was because this was the end of the proof. That EBD is congruent to EBC. EBD is congruent to EBC, and that's once again because you have side, side, side. We've shown that these three sides are congruent to these three sides. It's congruent to EBC, and you want to make sure you get the order right. So E is the angle opposite the three sides on this triangle, and it's also the side opposite the three sides on that one. And then corresponding to B, B is opposite the single side, and over here B is opposite the single side. So it's going to be EBC. It's congruent to EBC because of side, side, side. And let's check our answer. Drum roll. And it's right. Very good.